review, the Algebra 2 semester review and aware on number 14. Okay, they're asking us to graph the parent function of a quadratic. F of x equals x squared. That's the quadratic parent function. Hopefully, the majority of you know what the parent function looks like, but if you don't, and it's not working, Mom. There we go. Okay. The vertex is here at the origin at 0, 0. Oh, over here, you would have to, in aware, you're actually doing this in aware, not on paper. You would have to click on quadratic. Okay, x squared is a quadratic. Okay, and then you would drag the vertex to the correct spot, and then you would plot a second point somewhere so that it graphs it the correct direction and the correct width. So the parent function 1 squared is 1, or 2 squared is 4. Okay, and those reflect over on the negative side as well. So you could plot any of those other 4 as your second point, and it will automatically draw the curve for you. Now, if you don't remember the parent functions, if you're like, ooh, I did not remember what that was, then you need to make sure that you use Desmos. Okay, in Desmos, you could just type in y equals x squared, and you could see that parabola. You could say, okay, there's the vertex at 0, 0, and then you could plot any of these other points as your second point. Okay, so you can graph it in Desmos if you don't remember it off the top of your head. Okay, but that was the quadratic parent function. This one is asking about the domain. Domain is what? X values, okay? So what are the X values? Okay, if that's something you need to add to your reference sheet, you can. Okay, what are the X values of the function f of x equals the absolute value of x? So this is the absolute value parent function. Okay, it was just graphed in number 13. Okay, and the domain for all absolute value functions. You can pull this up in Desmos and graph it if you need to. But this is the absolute value parent function. It goes through 0, 0, and it goes left forever, and it goes right forever. So what are the X values of that function? How far left to how far right does it go? What does this arrow here tell you? How far left is it going to go? It's going to keep going left forever. What about this arrow? How far right is it going to go? Go forever. And are there any gaps or breaks or holes or asymptotes or anything? No, it's a continuous graph. There's no holes, no asymptotes, nothing. It goes left forever, it goes right forever. So what's the domain? All real numbers. It's everything. It exists at every X value. Okay, quadratic is going to be the same way. A quadratic function and an absolute value function's domain will always be all real numbers. Okay, those are continuous functions that go left and right forever. All right, number 16 asks what the vertex is. Okay, so that's that same graph. The absolute value function, the parent function, this one that I just reminded you of the graph of. Okay, where is that vertex that I just plotted right here? What is that location? Which of these 4 points is that vertex? I'll take it. 0, 0. Okay, the vertex is at 0, 0. You need to know what vertex is. Okay, it's at 0, 0. The vertex is at 0, 0 for both the absolute value and the quadratic parent function. The vertex only moves when you have translations. Okay, so if the function is translated left, right, up, down, then that vertex will move. Okay, but for the parent function, it's at 0, 0. Okay, and is that vertex in the parent function, is this a maximum or a minimum? Is it the highest point or the lowest point of this graph? Come on, guys. This doesn't get really much easier than this. Is this the highest or lowest point of this graph? The lowest. Is that a maximum or a minimum? Minimum means bottom, low. Minimum is the low point. Max is high. Maximum is the high point. If it was upside down, then it would be a maximum. All right, 17, same function, except this time it's got a negative in front. So again, you can go and graph this in Desmos. If you don't remember what this graph looks like, go graph it. Okay, but if you put a negative in front of it, it flips it over. This is what you would be seeing in Desmos. Okay, you would see the absolute value function flipped upside down because of that negative. Okay, so where is the vertex now? Did the vertex move? The graph flipped upside down, but did the actual point of the vertex move, or is it still at 0, 0? Still at 0, 0. The graph didn't shift, it just flipped upside down. So now, is that the high point or the low point of the graph? It's the high point, which is a maximum. Okay. So you need to understand the vertex, what a vertex is, and when it's a maximum versus a minimum. Okay. Number 18 says, finish the statement. F of x equals the absolute value of x is symmetric to, okay. Another word that could be in place of to is about, or over, or around. Okay. So it's symmetric about the what? Okay. What is its point or line of symmetry? Okay, so what could I fold it over? For line symmetry, it's a fold. So here's our XY axis. Here's the absolute value function. Yeah, I can scroll that at the beginning of class. I'm in the middle of recording a video now. Hey.
Hey.
All right, so there it is. There's the parent function. What line could I fold that over and it would be symmetrical?
On the CBA for Algebra 2, there's several equations that they give us. It's like real world situations. How do you know if it's linear or quadratic? I mean, my thing is I usually just try both and then I see which ones the dots are closest to, whether it's.
Oh, for the regression?
Yeah, like 26 and 20.
Let's go take a look.
26 and 29.
26. While we're on that one, guys, this is the line that we could fold it over and everything. Man, my pen keeps going out. There. We would fold it over this line and everything would match up. So that's the y-axis. That's our line of symmetry for absolute value parent function there. All right, we're going to skip ahead real quick. We got a question about these and we'll 26. Take a look together. All right, the data shown was collected.
We just typed it into Desmos.
Okay, so on your reference sheet, guys, they're giving us a table of values and then they want to make a prediction. So this is regression. And remember on this sheet that we gave you, there's the steps for linear regression and the steps for quadratic regression are the same except for what you type in, like after that squiggle. So let's go try this one.
And we've been using the little 4 dots in the upper left, but I'm not sure on Lockdown Browser if those 4 little dots will be there or not.
Okay. So we're going to insert a table. All right, so I would probably just try both so y'all can
see. Yeah, I just clicked on that and then because I could quickly try both. Note the little dots below that. that little 4-dot thing right there, and I just tried linear, and then,
I didn't even know that existed.
okay,
So
super
that's cool.
awesome.
Okay.
So I tried that, and then I
And
zoom in to
then-
see the dots to see if it's, of course, your R squared is pretty good, 0.95.
So our points are way up
It's
here.
not
Okay.
bad. Then you can just drop down menu and change it to quadratic,
Oh,
and it's 0.95 also. Oh, no,
0.95 for quadratic.
that doesn't look like,
Yeah, no, it doesn't.
maybe zoom out and see if,
And 0.95.
no, that's still linear.
Okay, so linear. Huh. That's weird. I'm gonna try it typing them in and see if it gives me anything different. I'm sure it doesn't.
It's hard to tell because if the regression is 0.95, but I'm thinking you're,
9527 9532. So I guess we would have to go with the quadratic because you want it closer to 1. Those are really close though. But your R
try
squared.
typing in the quadratic, because that doesn't, this picture doesn't look right, which makes me think we did something wrong, or it's not
Okay.
processing, so maybe get rid of.
Wonder, how do I
Yeah, you
get rid
can
of it?
delete, yeah,
Okay.
and then
All right.
type in.
So let's try Y1. We'll try the linear 9527. I think that's what it gave us. And then let's try it with okay. So here's the two different regressions, linear. Those are the same values that it gave us, but yeah, it's not graph.
Oh, there it is.
Okay, so it's graphing the parabola. So they want to know which one is the better fit. So that is really hard to tell when you're just looking here. So that's why we've got to remember, we've got to just base it on the R squared value. The closer to 1, the better the fit. So 9527 versus 9532, we'd have to go with the quadratic.
So you can get rid of that. I'll show you another, and you can come down and on this one. Oh, this is the one you plugged in.
Yeah, so then
I'll
we
show
can
you
add
that.
the, oh, I don't mean to duplicate.
That's a, yeah, well, you can, because then you can go in and
I just meant to
we'll go back.
make the table for it, but maybe not. I gotta type it, I guess.
No, you, well,
No?
you should go get rid of it and then do the drop down menu again.
Okay. So y'all see these dots under where you've got the table written? If you click on those, it gives you the option
So
for the
change that to
regression here.
quadratic.
So we'll put it in the quadratic.
And then go type on that little copy thing there, the little piece of paper right there. And now.
Oh, and it copies in the
And now you can come
equation.
back and change the X's to, what do they want? 42,000? Like,
Oops.
yeah, 42,000.
Okay, so the data shown collected from a group of camp. Project the height of 6-year-old Alex, who's 30 inches tall. Compared to Alex's real height, the prediction is blank inches too tall or short. Okay, so we want to plug in an age of 6. So we're going to replace our X's with a 6.
Oh, that's what I was doing. I was plugging in 42,000 for some reason.
Oh, well, that's number 27. That's the other problem.
Oh, okay. So I'm talking about two.
Yeah. So in this one, we're plugging in a 6, replacing that X. And so it's using this regression. It's saying that his height would come out to a little over 36, and he's actually 39 inches tall.
About
So the
3.
prediction is about 3 inches too short.
Yeah.
Okay.
Okay. So I was doing the next problem.
Okay. Well, we can look at the next one too. We'll just go ahead and talk about regression while we're here. All right. So let me then. So he was about 3 inches too short. We did, I'm just going to put it up here for y'all. We did quadratic regression. And we
Thanks,
plugged
Andy.
in 6 for X. And it came out to about 36. So that's where we got 3 inches too short.
I don't know the little 4 dot thing that we did on Decimos. I don't know if that's available on Lockdown.
Okay.
So if it's not, they're gonna have
to do the
they'll have to
typing
type
in.
it in.
Okay.
So,
Yeah.
all right, I'm gonna get back.
Okay.
I left Coach by himself.
All right. Let's go ahead while
So I
we were
guess you just
talking.
have to check your R squared each time.
Yeah, that's all I would do for sure is check R squared. Okay. So let me delete this one. I'm going to create a new, we'll go ahead since we're talking about regression here, since he was came by and asked about that, we'll go ahead and answer this next one. So again, those steps that I did to get the regression are listed here on this reference sheet. You don't have to have these steps memorized. If you bring your reference sheet that I gave you last week, it tells you you're going to hit the plus button, add the table, and then you're going to type in your data. So for we're on 27 now. This one says you have a budget of $42,000 to spend on advertising for your business. The two companies have provided you with the data on the profits based on the amount of advertising purchased. Which company is going to give you the greater profit, and how much greater would that profit be compared to the other? So we're going to have to do this twice. We're going to have to do company A and we're going to have to do company B, and then we're going to compare them. So first, company A, we'll fill in this data. Putting in now my Y's. All right, so again, it doesn't straight up tell you what type of regression to use. That's what Coach was just asking about, like how do we know if it's linear or quadratic? If they don't tell you, you don't know, and you just need to check both and compare that R squared value. Remember that R squared value, the closer it is to 1, the better the fit. So we want the bigger R squared value. So what he just showed me that I didn't ever notice before or know how to use this is this dot right here, this add regression. I feel like that must be new because I swear that didn't used to be there. But if it's not there on the test, then just use what's on the reference sheet where you type in the equation with that squiggle line and the Y1s and the X1s. But since this is here, let's go ahead and just click it and let's see. So if we do linear regression, our R squared is 0.7573. If we do quadratic, our R squared is 0.9208. That's much better. So definitely quadratic regression, and it shows you the graph over here. Okay, so then if once you have this, you can click on this little piece of paper here and it will type it here with those values. Ta-da! Okay, puts it in nice and pretty. Okay, or you could type that out and you could substitute in X. They're saying a budget of 42,000. So you could plug in for these X's here and here, 42,000. Or remember when you have your equation, okay, I could type in the equation again. And instead of actually plugging in the number, I could add a table for that equation and then just type in 42,000. Now it's giving it to me as scientific notation, so that's not really that pretty, so you may not prefer that. So let's do it actually plugging in the number. So in place of X, I'm going to put 42,000. X is in 2 places here. So make sure you plug it in both places. All right, so that's what we get for company A. So now we're going to, I'm going to get rid of this up here. Okay, so that's company A. Now I'm going to do the same thing for company B. So my table. Get all my data plugged in. Bless you. Okay, and then I can click those dots, or I could type in my regression equation. And you can double check, they should be the same, both quadratic. So that's 9509, 9971, definitely quadratic again. So here's that equation. I'm going to click there and get it. And then I'm going to plug in a 42,000 here. For my x's. Okay, so there is company B. Now it doesn't really make, that one came out negative. So I feel like there was maybe something wrong there. It's weird. There should be a difference of around 30,000 if you look at your answer choices. See if I have a typo in any of these and typed in. Yes. Okay, I'm going to make this full screen so I can see more of what is typed. It's kind of hard on the split screen. Sorry, because that did not make sense for that to come out to a negative. So we're just going to try this with a must one more time. So we're going to add a table. Company A. Y'all double check on yours. Maybe I had a typo in my table because that could make the difference. Double check with me. I've got all the values. 19, 17, 22, 26, 33, 72, 67. Oops. Okay. 133, 40, and 151. Quadratic. It's the better fit. Just double check. Yeah, for sure. Okay, so I'm going to get that equation. Let's look at the graph too. Ah, I know what I did. Okay. Easy mistake to make because look at this. We should not have been plugging in 42,000. The annual advertising that's in this table is already in thousands. So we should just be plugging in a 42, not a 42,000. That was my mistake. Okay, in both of these. So we should just be plugging in a 42 for X, not a 42,000. Okay. Well, I'm glad actually that I made that mistake so that you can see what would happen if you did it on the test. And so now you won't do that. So we're just going to replace the X now with 42. So there's company A. And again, this would be in thousands, so 78,000. Now we're going to do the same thing for company B so that we can compare them. So company B, 17, 20, 24, 35, 43. 69, 71, 86, 31, 100. These dots. Quadratic. Here, and then we're going to replace these x's with 42. Oops. Oh. I'm going to get them side by side. I'm going to get rid of this table. All right, so that was company A on top, company B on bottom. The paper back over here. So the better profits are going to be with company B. That is still a lot bigger than a $30,000 difference. Wondering. Should not have deleted those. Oh, good. I can bring them back. Okay. So let me double check my tables, make sure I don't have a typo. Look at this with me. So company A, 1972, 1767, 22, 133, 26, 140, 33, 151. Okay, company B, 1769, 2071, 24, 86, 35, 131, 43, 200. Okay, we did quadratic because it was 9971. Quadratic regression on both. Got all those numbers. Let's see, did they specify anything different to be rounding to? Maybe we used too many decimal places. I don't think it would make that huge of a difference. Those graphs too. So 42 and here. Yeah. Numbers. That green one, the 42 is way up there. Oh, that's 43. There's 42. Okay, I'm thinking it must be a typo in the actual review because it's not matching up. But as long as you understand the process of putting the table in, getting the regression equation, and checking to see what you should plug in. Okay, so here we plugged in 42 instead of 42,000. So I'm going to make a note of that. Okay. We're going to plug that into the regression equations and compare. That was what you should do. So we did quadratic regression for both to get equations, and then we plugged in that 42 to compare. Okay, so we get that company B Which company had the greater profit is B. So A is out. These numbers are just off. Like this is a typo. So don't worry about what you select in Aware and getting it wrong. I'll give everybody the credit for this one since there's got to be a typo somewhere. But definitely B here, company B had the higher profit, 189,000 versus the 78,000. Okay, so yeah, I think there's a typo somewhere in one of those tables on the actual review, but that's okay, it happens. Okay, so that's the regression equations. 26 was regression also. You weren't having to compare, so it was a bit easier. You just had to do one table and then compare it to the actual value they gave you. See if there's another regression one. Is there a regression one before this? No. Okay, let's go ahead and do 28 here while we're talking about regression then. This one gives us a table of shopping distances for a car at different speeds, assuming that the road surface is good and the driver is alert. So you have the speed, and then you have the stopping distance. If X represents the speed and Y represents the stopping distance, use a quadratic. Now this one tells you quadratic regression. So you don't have to check linear and quadratic and see which R squared is better or higher or closer to 1, however you want to think of that. They just tell you use quadratic. Okay, and we're going to use it to estimate the stopping distance for a car traveling at 50 kilometers per hour. So that's the speed. So once we get our regression model, we're going to plug in 50 for X. And then we're going to round to 1 decimal place. Okay, so let's go ahead. Pull Desmos back up here. Split screen that to enter this table. All right, so the steps again, one last time, regression steps. Add table. Enter all of your data from the given table in your question. Okay, double check that you don't have any typos. Y'all call me out if you see me mess up with a typo. Okay, and you can see those points are plotting on your graph over here as we type them. So we can use this little add regression. Go to quadratic regression. Okay, and they give us the equation that R squared's pretty high. That's good. That means it's a pretty good fit. You can see the line there when we added the regression. It goes through a lot of those points. So we're going to copy that equation down here, and we're going to plug in for X. What did we say we were plugging in? 50? Because it wants us to make a prediction, yeah, when the speed is 50. So I'm replacing X here with 50. And X is in 2 spots because this is a standard form quadratic. Okay, and then round that to 1 decimal place. So 26.8823, that 8 would round this 8 up. So 26.9. So that is answer choice B. Okay, so let Desmos do the work for you. You have to understand what to type into Desmos, what to do in Desmos, but it's doing all the calculating for you. So you just have to be sure that you type carefully and follow the regression steps. And again, the regression steps are listed on that reference page that I gave you, okay, that you get to use as long as you bring it back with you. And you can make little notes on it. So if you want to go here to regression steps and make the little side note that, hey, those little dots will appear in the left corner and you can just click on that and the regression equation will appear. Okay, add whatever you want to that reference page. Okay, I think that was it for regression. Looks like it. So I'm going to jump back up to where we were working before. We're on 19. Okay, so let's take it back to 19. It says, given the vertex of a parabola at 1, -4, the parabola opens downwards. Which of the following is the correct equation for the parabola? So again, with any of our functions, it's not just parabolas, it's with those absolute value functions as well. You've got to know your transformation rules. So your x is inside with the h value. H is subtracted from x. So remember that that h is telling you your horizontal shift. Okay. Okay. And your k is telling you your vertical shift. And your A is telling you your vertical dilation, which is a compression or a stretch. And remember, it's a compression if A is less than 1, it's a stretch if A is greater than 1. And then if there's a negative A, it flips the graph over. Okay, so now they're telling you your vertex. Remember that your vertex is HK. That's telling you that horizontal and vertical shift. So they're telling you that this graph is shifted. It's a positive H1, it's to the right 1, but in the equation, that's going to be a minus. So it's going to be -1 inside and then a -4 outside, what we're looking for. So -1 is good. These two are out. And -4 on the outside is good. Okay, so the only difference in A and B here is the positive, understood positive A or a negative A. And the fact that they told you here that it opens downward, that tells you you've got the negative. So that one should be B. Okay. I'll be here for additional review sessions in the afternoon starting tomorrow if you want to come. But I'm also going to post links to the videos going over the entire review, so you can use those videos if you get stuck on any.